quick announcements if that's okay. All right, so welcome to the session about creating an automatic management of Lambda infrastructures with Giorgio Tavecchia and Matteo Di Piero from Quantyca. We're so glad that you're interested to learn more about this topic. Before we get started, we have just a couple of announcements. During the presentation, as the presenters are sharing slides, you can double click on those slides to make them larger on your screen, which might help you if you'd like. So Giorgio and Matteo have said that they welcome you to ask questions in the chat while they're talking, and they'll probably answer those questions after the presentation is done. So feel free to chat in the session if you'd like. All right, so without further ado, let me introduce our speakers for today. Giorgio Tavecchia and Matteo Di Piero are with Quantyca, an Italian technology consulting company. They'll give a deeper dive into their background during the presentation. So without further ado, I will turn the time over to them.
Okay, thank you, Lisa, and welcome everyone. So, welcome to this session. You can see, okay, perfect. So this session is titled Create an Automatic Management of Lambda Infrastructures with Custom Practices for State Development and Testing. So as you can see, the title is quite long, but don't worry, most likely you will not fall asleep, or at least we hope so. So let's start by introducing ourselves. We are Giorgio and Matteo, data engineers from Quantyca and members of the site and reliability engineering team. Here is the agenda for this session. We will start with a brief introduction on the use case in order to put everything in context and giving you the project overview. We will go on to list the challenges that we faced and some of the project requirements. We will move on to the solutions. We will have some technical implementation, and Matteo will show you some demo. Finally, we will conclude with some benefits of adopting SaltStack in this particular use case and with our customer. So let's start with an introduction and the project overview. And first of all, let's talk about who is Quantyca. So we are a consulting company specialized in data management and data strategy. On the right, you can see some of our main core focuses. So for example, data integration, big data, cloud, and data-driven services. So as you can see, this is a very broad context that often requires the adoption of automation system for data management. And then we have our customer. So who is Rinascente? Rinascente is an Italian brand that owns a number of high fashion stores in main Italian cities. They focus on design, art, and made in Italy. So let's see this project overview. Basically, Rinascente decided to move on and enter in the e-commerce world. So basically, so far they had only physical stores, and they now want to embrace an even wider audience. In order to do so, they needed an important information. This is the real-time stock information continuously updated. And to compute this information, they equipped themselves with a distributed stream processing architecture. The idea is that with this architecture, they are able to analyze in real time all the variations in the stock due to in-store sales, online orders, or inventory movements, for example. So far, nothing strange, you will say, right? Where is the problem? Let's dive into more detail of this architecture. As we said, we have a real-time stock that is now computed with a distributed stream processing architecture. But of course, Rinascente already had the stock information. This information was computed in a different way. In particular, in a batch manner. Basically, they computed this stock once a day. And the main challenge that we need to face is that they consider this information as the master one with respect to the stock. So basically, the correct one. And they need to design a process to align the real-time stock with the batch stock. That is our first challenge. Then let's go into more detail about the real-time stock. As we said, it's the result of a distributed computer architecture. So basically, you don't want to think this as a giant application deployed on a single node in which all computation goes through. In fact, we have 10+ nodes, each node has a different role, so basically you have different applications deployed on different nodes. And of course, we don't have a giant application, but we have 8+ streaming application services. So what does it mean? That in order to perform this alignment process, we need to orchestrate all of these components. So now you're starting to understand the main problems that we need to face and the requirements that are need to meet. So let's move on to the challenges. And first of all, let me say that the realignment process is business critical. What does it mean? Basically, you don't want to go to the e-commerce and not be able to buy something because the system says that there is no stock for that product, where actually it has, there is stock. Or on the opposite, you maybe place an order and some day later you receive an email and they say, oh, sorry, actually we don't have that product, so try again later. The idea is that we need to satisfy different functional and non-functional requirements. So let's see what are the requirements that we have to meet. First of all, we need to integrate a system or an automation tool that is easy to adopt and integrate. So basically, we don't want to provision ad hoc nodes to enable this alignment process. We don't want to add many services or requirements, and of course, we don't want to spend a lot of money to ensure that because we need high computational power to perform this alignment process. Then, as we said, we have a distributed architecture. So basically, we need to coordinate different applications deployed on different nodes. And we want to make sure that this communication is secure, since it is all business critical. Then we want a system that is responsive to events. What does it mean? Basically, we want to reduce and minimize the overall time needed to perform the alignment process. And then, of course, we want a system that is fault tolerant. So basically, we want to be able to perform some rollback step and not leave the stock information dirt. Now, let's additional requirements. For example, we want a system that is schedulable. So basically, this batch stock, it's computed once a day and not once a month. So you can have one single person that performs this alignment process, but you want to schedule this process every day and every night in particular. Then we want a system that is flexible with respect to new specification and architectural changes. So the idea is that if tomorrow you want to add some steps, some services to the alignment process, or maybe you just want to scale up your cluster because you need additional computational power, you don't want to rewrite all the alignment process from scratch. And then last but not least, you want this system to be observable. So basically, you want to know at each time what is happening, what has happened so far, and so on. So somebody say Salt. Basically, it's clear that given the architecture and the requirement just described, SaltStack is really ideal to meet all this thing. So in this slide, we have an overall recap of the requirement that we just saw, and the main features or components in the SaltStack architecture that ensure us to reach these requirements. If you are already familiar with Salt, this is really straightforward. In any case, we can say briefly, for example, that the secure communication between minions is ensured because every communication between master and minions is encrypted, for example. And then you have different components such as the Salt Reactor system, the Salt orchestration, or the scheduling system that ensure you to be responsive, fault tolerant, and of course you can schedule all your jobs. Don't worry, we will go into more detail about these components in a few slides. And then finally, for example, with respect to the observability concept, we have the event bus that is easily readable, and so you can interact with it and see what is happening. So let's turn page and move on to the solution. So basically, we want to dive in to discover how we use these components in the Rinascente use case. So let's start with the scheduler. We have mentioned it previously, and now see a practical example. The idea is that the Salt scheduling system allows us to schedule activities on the master and on the minion. On the right side, you can see an example that can be easily enclosed in an SLS file. Basically, we have only 10 lines of code that are really powerful and flexible, and then can ensure us to apply different scalation and change them programmatically. So let's see the code. Basically, we have the first line, in which we have orchestrator scheduler, that is our ID to identify the scalation. Then we have the function schedule.present that ensures us that a job is present in the schedule. At the same time, you can, for example, use the function schedule.delete to remove a previous scalation and so on, so you can change it programmatically. Then we specify what we want to do when the schedulation is triggered. So we have the function. In this case, we have a state apply with the parameter that is the state to be applied, that is rinSaltOrchestrator.trigger. And finally, we have the time specification. So basically, we say that from 1 a.m. to 5 a.m., we want to perform this action every 5 minutes. Okay, now we have our example. How do we apply it? Well, it's rather simple. We simply target a minion and perform a state apply with the code that we just saw. With respect to the Rinascente use case, we have a database in which we can see the information about the batch stock being computed, and we have our scheduled process. The idea is that during the night time, we trigger this check on the database to actually see if the stock has been correctly and completely computed. And if it's so, we basically receive this information and react by sending an event on an event bus. Let's see, so what is an event, what is an event bus, and most of all, the reactor component. So SaltStack is based on the concept of event bus, on which all communication between minion and master goes through. And we have the Salt reactor system that is always listening to the event bus and therefore can react if a particular event is received. But what is an event? Well, basically it's composed by a tag that is a human readable string, for example, and a data structure that is a key value dictionary. So let's leave the theory and watch a practical example that it's really similar to the Rinascente use case. So in this case, you see conditional execution based on the result of 2 different queries and a check on a grain value. And if the condition is satisfied, we simply apply the function event.send to send an event on the event bus. And in this case, we have the parameter name that specifies the tag. So in this case, Rinascente/orchestrator and so on. And then we have the data structure that is composed by a single key value pair, where the key is orchestrator and the value is run. Finally, we have the reactor that is really simple in this case. We have a conditional execution based on the value of the data structure. But for example, you can apply some filtering operation based on the tag. And basically what we do is checking if in the data structure there is a key orchestrator and the value run. If this condition is satisfied, we apply the state orchestrate runner on the module rinSaltOrchestrator.orchestrator. The Rinascente use case is really similar. So basically we have our event with the tag and data structure, and our reactor perform a check on the event that we received. If we match a particular condition, we start to orchestrate all the alignment process between minions. So, as we said, now we are able to schedule, to react, and then we apply states. So, what is a state? A state is a representation in which a system should be. So, basically, when you write code in SaltStack, you don't want to define what to do with your minions, but basically the resulting state that you want to reach. So let's see a practical example. In this case, we have the install network packages ID. In this state, we want to install some packages. So we call the state function package.installed, and we pass some arguments that are the name of the packages that we want to install. So rsync, ltp, curl in this case. When we apply this state, we can do it many times because the result will not change it, because the the state concept is based on the context of idempotence. So basically, the first run of this state apply will effectively install these packages, and any other time that you call a state apply on this state, all the packages are already installed, so the result will be true, but nothing will be done. The idea is that SaltStack provides us with a huge variety of different salt functions that basically cover 90% of the use cases. But of course, SaltStack is really flexible, so you can easily develop custom states in Python. Here on the right, we have an example that is really easy, but also very powerful. So we start with a virtual function in which we can, for example, return a string that is the name of our state, or a Boolean value. In particular, the Boolean value is used to dynamically enable the state if some system checks are verified. Then, in this state, we have a function, but we can have also many other, that is called start. And in this function, you can perform all the Python code that you want. So it's very flexible. You only have to return a particular dictionary that is composed by different parameters. For example, we have the result parameter, in which you indicate, that is a Boolean value, in which you indicate if the state function has been correctly applied or not. The changes parameter, that is another dictionary in which you can define, for example, what have changed from the execution of this function, and then the comment parameter in which we simply define a human readable string. One last component we used are salt engines, that are long-running processes that allow you to enrich salt with additional features. An interesting detail about these salt engines is that the salt itself takes care of monitoring them and restarting them if some error occurs. In our case, we use the Slack engine that is really useful to read and write messages from Slack. The idea is that writing messages from Slack, we can ensure the observability requirement. And so basically, as you can see in the example, we are constantly updating everybody who reads the chat about the current state and what are the previous steps that has been executed. Of course, you can also read from Slack, and based on that, you can react and apply some logic, for example. Okay, so basically we have described all the building blocks, and now we need to connect them and orchestrate them. Let's model our orchestration. So basically, you don't need to understand the right diagram. We only want to show you the main components. So basically, we have the first part, that is the scheduler. So we perform some checks on DB, and based on that, we send an event, as we saw. Then we have the reactor that is triggered by particular events that basically start the orchestration. The orchestration is simply lots of logic between minions. And how do we apply this logic? How we control this logic? Well, we have the state orchestrate runner that is that gives us a master level control over ordering and the conditional execution of a state apply, for example, on different minions. So let's see a practical example that is a simple orchestration that is really easy, but also very powerful. So let's start by the first line. We have a macro that we use to send message to Slack. The idea is that we configure the Slack engine somewhere else. We define our macro to send some maybe predefined messages with just custom parameters. And then we are ready to go. So basically we can use this macro to avoid to repeat code, and as we will see, we send a message by just one line of code. Then we have the step B, that is the first step that we see in our orchestration, but it's not actually the first step that is run in the orchestration itself. As you can see, it is a state apply function on the SLS file specified that is called simply step B, and we have a required parameter on step A. So basically, we are saying that the step B will be executed only if the step A has previously been executed and the result is successful. Otherwise, the step B will not be executed. Then we will see our macro function. We see, for example, that here we pass 3 parameters. The first one is the name of the step of the orchestration, a code to represent the step of the orchestration. Then we have the second and third parameters that are used to define an implicit required statement on the previous step. So basically, we send the event on Slack only if the step B has been correctly executed. Then we have the step C, that is related to step B. We have also a required statement. It's also a state apply. The main detail of this state is that we are targeting different minions with respect to step B. So in step B, we have to target CP host, and now we have a list of target. The powerful idea behind the state orchestrate is that you don't always want to apply the same state to all the minions, but often you need to apply some state on some minion and some on other, for example, based on different application services that are deployed on different minions. And then finally, we have the step rollback that has now an on-fail parameter on step C. The idea is that to ensure, for example, fault tolerance. So basically, imagine that this is our alignment process, and something goes wrong during the process. We are able to apply some rollback function. And so what actually happens is that step C is executed. If step C concludes successfully, the step rollback will be simply skipped. Otherwise, the step rollback will be executed, and so we can perform all the logic that we want to recover from the main error. So now Matteo will show you some technical implementation and a demo of the orchestration. So Matteo, okay, I'll give you the screen. So let me, okay.
Okay, wait. Okay, now let's talk about the technical implementation of our solutions in Quantyca. But before starting, let's analyze together the technical problem that led us to the definition of new practices. First, since in Quantyca we are mainly software developer, the standard way of developing solid state is quite unusual for us. So it's difficult to develop new state or work on states developed by others without a deep study of the technology first. These facts led to states developed with non-uniform styles, and this slowed down the communication and collaboration within the team. So we define our custom practices. These practices consist in 4 main points. First, we want to use the Python renderer instead of the default YAML renderer. Then we define a custom standardized folder structure for our states and pillars. Moreover, we prefer to use Git to apply remote state instead of saving a state file inside the master file system. Finally, we want to test our state using kitchen salt. Now let's analyze in depth these 4 main points. You probably are wondering why we prefer to use Python instead of the default YAML renderer. As I said before, in Quantyca we are mainly software developer. So for us, it's easier to develop using a programming language like Python. Moreover, Python enables us to use a programmatic fashion, and we can easily apply custom logic to our state, keeping the code elegant and readable. In fact, it's okay to use YAML and Jinja for a small state with few logics. But as the complexity of the project increases, the code will become very hard to read, understand, and edit. Now I'm going to show you an example. On the left, you can see a snippet of a Python solid state written in YAML. On the right, there is the same state written in Python. Since the slide is small, it may not be immediate to understand why we prefer Python and what are the benefits of using Python. But anyway, let's analyze these snippets. First, on the YAML code, we can see that we access the value of a pillar. Then, inside the state declaration, we apply a custom logic. This logic can change the behavior of the state declaration according to certain conditions. It seems okay, but what if the complexity of the state grows? The code will become hard to read, hard to understand, and hard to edit. On the other side, we have the Python state. And here we can see some of our custom practices. First, we define all the variables with grains and pillars values. Then we form the body of the state declaration step by step, applying custom logics and some loops maybe. And then we pass the body of the state declaration to the state declaration and return it. So how can you convert a YAML state to a Python state? You just need to apply a few guidelines. First, every list and dictionary in YAML become list and dictionary in Python using square and brace brackets. Then, on the top of each file, you need to add the marker to tell Salt that you want to use the Python renderer. Moreover, every state file must have a run function. This function must return a dictionary containing identifiers as keys and the execution of dictionaries as values. Let's go back to the example that we showed before. So here you can see the marker on the top of the file, the YAML or the Python snippet. Then you can see that a dictionary in YAML becomes a dictionary in Python with brace brackets. And list in YAML become a Python list with square brackets. Finally, we have the run function, where we initialize an empty dictionary and we fill it with a state declaration. Finally, we return this dictionary. Since we prefer to use Python for every project inside Quantyca, Python is not always the best solution. It is easier for developer and you can write clean code even with more complex projects. Moreover, it has a faster rendering time, but on the other side, YAML is easier if you have to develop some simple project with very little logics. Moreover, the documentation is written in YAML, so you can find snippet of code online and reuse it on your project. And of course, it's easier and more intuitive for non-dev people. The second main point of our custom practice is about the state structure. This point has three principles. First, we want to split our project inside components. This component can be reused in more than one project. Each component has a standard structure and has the same identical files as other components. Finally, we want to centralize configuration pillars. Pillars are just a variable that rely on the master and that minion can access. We want a centralized file with all the parameters of the project, more a file for each role-based parameter. But let's go in depth in the component structure. Each component must have three files: requirements, execution or deploy, and config. All your state declaration must be split between these three files. Of course, we have an init file that includes them, and we have an archive directory where we store every file that will be used during the automatic procedure. On the pillar side, we have the config file where we store every parameter common for all the components in the project. Then for each role, we have the role_role name file. And finally, we have the top file where we assign config to every minion and the roles to each minion. Here you can see an example with our structure. In this example, the Hello World as a service, we want to set up an environment with some node server and an Nginx load balancer, that load balancing within them. On the right, you can see the tree of the project. We have two distinct modules, load balance and node server. Both of them have the requirements, deploy, config, and archive with some configuration file or service file. For pillars, we have the config with all the common-based parameters, and for role-based parameter, we have roles load balancer and roles server. The third point of our practice is about Git. if you save your salt file on the master file system, you have to develop them on your device, then copy them on the master, and keep the master updated manually. But if you prefer to use Git with few lines of configuration on the master, you can develop your state on your machine, then push them on a Git repository, and Salt will look for states to apply on the Git repository. Moreover, thanks to a system like Git, you can apply a branch-based approach to speed up your development and releases. Finally, we talk about testing. Testing process in Salt is quite hard because you need to create virtual machines or containers, then install Salt in the master, the minions, and configure them. Then, when something goes wrong, you must have to destroy the machines and restart every time. And this is a very long process. Kitchen Salt will help us in performing this task and it speed up our development. Now, we want to show you a demo. Okay, in this example, we will create one master and 3 minions with Docker containers. Then we will set up an environment similar to the Rinascente one, and finally we simulate the alignment process of Rinascente. Okay, so let's start creating our Docker container. Just speed up. We already create our Docker files, so we just need to build the images and run the container. Let's just speed up a bit. Okay, now let's create our minions. We run them in privileged mode because we need to manage services. Okay, now we have 4 containers running, 3 minions and one master. Now let's access to the master and accept the minion keys. Okay, let's verify that the communication with minion are working. And refresh pillars that we will need later for the next steps. Okay. Now we can start with the setup of the environment. On the left, you can see the structure of our component setup with requirements, execution, and config. Of course, the init file that include them, and an archive directory. In the archive, we have the services for the stocks and the script for aligner and rollback. The stock service will simulate the stock of Rinascente, while the aligner will simulate the script for the orchestration. Let's analyze the code. The requirement we just installed some package that we will need. Then, in the execution, we perform some task to create our services. Pay attention on the first few lines where we, thanks to Python, we use string manipulation to create useful variable and access pillars values. Then, after a few steps, we have one more step. In this case, only one minion, the minion with is aligner true in its pillars, will receive the aligner script. That's because stock run on every minion, while only one minion will be the aligner. So only that minion will receive the align script. Finally, we just run the stock service on every minion. Okay, now let's access the master again. And as you can see, we still configure the master to read state from Git. Let's check the pillar to check if everything is okay. Okay, every minion has role client, while salt minion 2 is the aligner. As you can see, we don't have any setup module inside the root of Salt, so we're using Git for real. Then we can start with the setup. Okay, let's go faster. Okay, everything goes well. Every minion will have 6 succeeded steps, except for minion 2 that has 7, because it also received the aligner script. Now, to check if everything goes well, just check the status of stock services, and it is running on every minion. So we can proceed with the third step, the orchestrator step. The goal of this the orchestration is to stop the services on each minion, the stock services, then run the alignment, and finally restart stock services. So let's analyze the component of the orchestration. We have the scheduler that trigger an event sender with certain parameters. The event sender just run a message on the event bus, that is orchestrator run. Then we configure the reactor to catch this message, and the goal of the reactor is to run to start the orchestrator. Let's analyze the orchestrator code now. First, we stop stock services on every minion with roles client in its pillars. Then, here is the stop service. Then we start the aligner only on the minion with align true in its pillar, so on minion 2. Finally, we restart stock service everywhere. Now, on the right, in the terminal on the right, we will listen to the event bus to read every message that runs on it. Okay, now let's apply the schedule to one random minion, for example, on minion 1. Okay, let's check if our schedule list is as we want. Okay, minion 1 has a scheduler. Now, for the example, we will run the event sender by hand, because we don't want to wait until the schedule time. So, on the right, you can see that we catch the message, and the orchestrator starts. So the stock service goes down. Now, as the alignment succeeds, okay, we expect that our services goes up again, and that's true. So everything goes well. As a final step, we will add more piece of code on our orchestrator, the rollback step. When the alignment goes wrong, the rollback will run a rollback script. Now we change our code and just push our change. Okay, this time let's run the orchestrator by hand. Okay, it's running. Okay, orchestrator goes well. Of course, since nothing failed, the alignment didn't fade, the rollback piece will be skipped. But the important thing is, since we skipped it, that it has been evaluated. Just because we push our change on Git without any other steps. So now let's talk about benefits of our solutions. We have two kinds of benefits, technical benefits and business benefits. On the technical side, thanks to our practices, we are more developer-friendly, so our style is more suitable for developers. Then we have a standard structure, so it's easier to start to develop new state or work on state developed by others. Finally, thanks to our component-based practice, our component could be reused in more than one project.
And finally, we have also some business benefits. So, for example, we have the cost reduction. The idea is that we don't necessarily need to provision ad hoc nodes, or we don't need the high computational power to run the minion and also the master. Then we have the risk reduction. So basically, SaltStack is really reliable, and so you can ensure that adopting it and use it to automate a process like the alignment process, you are reducing the human error. And finally, as we saw in the demo in the previous slides, SaltStack is really flexible, so you can be sure that you will meet all your future requirements and demands. So that's all for us. Thank you for joining, and if you have any question, we are here for you.
All right, that was seriously awesome. Thank you so much for sharing. And for one, I just want to say that I really loved the slides with all the images and things like that.
Thank you, Lisa.
Really nicely done. I have a feeling it'll be the best I see today. So, but yeah, really nice work. So now is the time where we're going to open up the session for Q&A. I have a couple of questions that I can ask to get us going if we need, but let's just take a moment and see what questions you have first. Go ahead and ask them in the chat, or if you want to, raise your hand and ask them in person by sharing your video. All you have to do is click the share audio and video button on your screen, and I will let you in to ask your question. Okay, so it looks like we do have some questions starting out, and our conference people have told us to please read the question out loud for the recording later. So the first question we have is there a link to examples of this orchestration?
Okay, not in this moment, but we obviously provide you with a link with all the code and also the slides, obviously, to try something like that.
Very good. And of course, the recording will be available later, so people can kind of look more closely after it's over. So yeah, okay.
But on GitHub we have the code of the example, the simulation of the orchestration, if you want.
Very good. Other questions? Does anyone else have a question? Very good. So now the link is there in the chat for the demo. Very good. So I have a question for you. How long did it take from end to end from the design process where you got the requirements for the project until you were able to implement it commercially? How long did that whole process take?
Okay, so I don't really can give you a number because I don't know it. But it was when the requirements were all written down and all was clear. We can say that the development process was really straightforward. So basically, you know every step that you need to perform, and with SaltStack you can deploy each single module once at a time and testing, run it on the test environment, and it's really easy to add additional specification. For example, if you want to add the new steps, that is something that has really happened, and so we have our initial orchestration, and then we move on. We add additional requirement, additional step, and I think it's really straightforward with the SaltStack. So thank you for the question.
Yeah, awesome. I have another question for you. What's the biggest advice you would give to somebody who is getting ready to set up an orchestration for the first time and is still like learning how to get that whole process up and running? Are there any best practices or things that you learned from this project or past projects that you would recommend for somebody trying an orchestration project?
I don't know. Yeah, what do you want to respond? Of course, our best practices are our company best practices, so you are really free to adopt every style you want into writing the orchestration. And the idea is, I think that the best idea is to module each step of the orchestration. So basically, don't write all the code in a run and then expect that everything goes well and so on. So let's take a few little steps and then add additional steps once after other.
Yes, of course. We recommend our best practice because we develop them just for our organization to start developing in a standard way and faster. So that's why we invented them. So we advise them.
That's awesome. Yeah, and that's just good advice for programming in general. Like build a little piece, test it, then add another piece, test it.
Yes, exactly.
Yeah, exactly. And plus, it seems like you mentioned in your presentation that you have a kind of a modular design so that little pieces can be plugged in and taken out so that you can plug it into a different project with different requirements later. That also seems like a really good best practice because then you're building each little piece at a time. You can take a piece in and take a piece out, that kind of thing.
Yes, exactly. So the module idea is really useful, and so we based all the development on this idea, and we actually had the case in which we needed to adopt some steps that we already developed. So basically, we take the module, apply somewhere else, and we are ready to go with the little changes maybe, and that's all.
Was this your first orchestration project, or have you done a lot of these before?
For me, it's my first orchestration project.
Nice.
For me too.
Very cool. Well, I'm really impressed with what you did with your very first one. That's awesome. I think it's a really cool, sophisticated use of Salt. How long have you been using Salt for projects? Like, how long did it take you to kind of get up to speed and learn all the technology?
Right now, I think I'm using SaltStack by 1 year or something more. And so personally, but also Matteo, we had a good mentor. So that was really useful to start up, obviously. And that's it, I say.
Oh, very nice. Well, that gives me hope because like I feel like I have so much to learn about Salt, and it's good to know that yes, you can pick it up pretty easily with a good mentor and things like that.
Yes.
Cool. Does anyone else in the room have a question for us that you'd like to ask? I don't mean to monopolize the conversation. Feel free to ask some more. So. Well, sure nobody has a burning question you want to ask in the chat. All right, well, I think our session is nearly done anyway. We're supposed to end in the next 3 minutes, so let's maybe end the session for now. But thank you so much. That was a super interesting presentation. I personally hope to go back and review it a little bit later. Maybe we can turn some documentation into it, out of it, and we'll be good. Oh, look. Okay, so we do have a question. Sorry, let's take one more question then. The question is, how do you debug a state written in Python? So you mentioned that you're not using YAML, which is the standard for Salt. You're converting it over to Python for your own reasons. How do you debug a state written in Python?
Until now, we just run our code and try to understand what happened and why it failed. But of course, we have to develop a new way of debugging and add it to our custom practices.
Nice.
Maybe next year we will have the answer to this question.
Perfect.
That's a good answer.
Got another question. Have you looked at integration with local stack Moto server with your testing?
Actually, no, but that's a good point to solve in the later on.
Nice. Very good. Okay. Well, we'll wrap maybe just a couple minutes early, but thank you so much. That was a really awesome presentation and I learned so much. So thank you.
Thank you, Lisa. Thank you.
Thanks everybody for coming.
Bye.
Bye.
Bye-bye.